you put 3 dots randomly on a 1x1 grid, you can always make a triangle. Then you can find the area of the triangle. If you keep doing this, you can take the average. And over time, you will find the area of the average triangle. But what is that number? And what does it look like? What would the average triangle look like? Is there some way to work this out? I started wondering about this when I saw a video about 2 candles on a cake from Numberphile, but they just used a simulation. They didn't find an algebraic answer. So I tried to solve it myself, but I found it extremely difficult. So then I asked ChatGPT. ChatGPT actually managed to get this wrong 5 times. And I was so confused. Why is this so difficult? I went to Wolfram Maths World, which is usually the best site to explain such things, and it told me this. The solution was first given by Woolhouse in 1867, since attempting to do the integrals by brute force results in intractable integrals. That's the problem I was having. They were intractable. The best approach using computer algebra is to divide the 6-dimensional region of integration into subregions using cylindrical algebraic decomposition, where apparently you end up with between 32 and 4,168 regions to give the mean triangle area 11 over 144. Now, obviously, I'm not going to do it like that. So there must be another way. If you think about just throwing 1 point randomly on a line, it's pretty obvious that the average point will land in the middle of the line. And calculus and integration shows us that. And if you want to see why, I did make another video which you could watch. But what about the 2-point situation? Well, again, your intuition might tell you that eventually, if you keep doing it and average them out, the 2 points will split the line into 3 equal segments on average. And that is what calculus tells us. So it all makes sense this far. You can split the area between one more than the number of dots. And the same thing happens in 2 dimensions, that if you do it enough time, you will split the x and y into a third, so the average rectangle will be a square, area 1 over 9. So why can't we just have the same approach with 3 points? Well, strangely, the calculus just breaks down. And I made another video about that if you want to watch it. Or you could try and do it yourself. But you don't have to, because this is the solution. This is the conclusion of the triangle trilogy. We're going to try this geometric probability approach. Because there's 3 dots, we're now going to split the x and y into 4 equal parts. And on each of those dividing lines, we'll put 1 point in the x and in the y on 1, 2, and 3. And it turns out there's 6 ways you can do it, but only 4 of them are triangles. 2 of them are the straight line, the diagonals. For the first triangle, we can simply organize the square into triangles using normal geometry. We know it's a half in each direction, and so we work it out as 1 over 16, 1 over 16, 1 over 32 in those outside corners, so 3 over 32. But now, the straight line, what do we do? Now, we've been averaging so far, so your instinct might be to put the blue dot there. Average that way, that's in the middle of the square. That's the geometric center. However, that is not how this works, because you have to remember how the square, we are going to find the area of the triangle by the base multiplied by the height. the base will be the distance from red to yellow. So the height will be the distance from the center line out to the blue. That height is changing along that line, but if you extend outwards through the full space, you will see the area where the height will be low is bigger than the area where the height will be high. So we need to deal with this by breaking it down into strips for the area. And below h has more area, you must use the dreaded double integral. You integrate the height once to get the area, and integrate the area as a probability function to get the average. As we integrated the areas to get the average earlier, you get to a half minus 1 over 6, which equals a third. This tells us that it will be a third of the way along this line H that we put the blue dot. So if that's a third of the way, then by base times height, the area of the triangle will be a third of the big triangle, which is an eighth. So a third of an eighth is 1 over 24 for the area. So at last, we remember that there's 2 straight lines and 4 triangle shapes made by the dots. So that's a ratio of 2 to 1 of the 24, 1 over 24 to 3 over 32. We just multiply that out. In a ratio, we get 11 over 44, the answer we've been looking for.